Good afternoon. Today we have another new topic that I'm going to talk about. A new subject, and this is science. It is science. Today it is science. I believe you are going to enjoy science today. Now, so far so good. We talked about a lot of things, but now in mathematics. But now let's see science. We are going to talk about energy. Can you say energy? Now, energy is a topic 2 in grade 5 science textbook. I'm going to discuss it in details, but wherever I reach, I'll be giving you extra work that I'll send on the email, so that you can do it and we discuss and so on. So I want you to listen and listen very well, because if you don't listen and make short notes, when you go to get the work that I've given you, you will not do anything. Now, let's go direct. By the way, this is brec.tvonline, and I'm the teacher, Kisikitewani. Let's go. Energy. What is energy? Energy is the ability to do work. We are talking about, the topic is energy. So we have started. The topic is energy. This is the topic, energy. Now, want us to discuss it and know what is energy. So energy, it is the ability to do work. The ability to do work. I want you to listen very well. This is ability. Ability. The ability to do work. Now, what do you understand by ability to do work? It means that any work that we do, we use energy. We apply energy for the work to be done. For instance, talking, I'm using energy. If I decide to push this wall, I'm using energy. If I decide to punch that camera, I'm using energy. So, ability to do work, any work that you do, that is energy. Are there? Now, there is a law of energy that states, the law of energy that states that energy can never be destroyed or created. Energy can never be destroyed or created. But it can be transformed from one form to another. What does the law of energy say? Let's go together. Energy can never be destroyed or created, but it can be transformed from one form to another. Let me just write that. Law of energy. Of energy. What does it state? It states that energy can never be destroyed or created. Energy can never be destroyed or created. But what happens? It can be transformed from one another, but can be transformed. It can be transformed from one form to another. So, wherever anybody asks you to state the law of conservation of energy, wherever anybody asks you to state the law of conservation of energy, you just say energy can never be created or destroyed. Created or destroyed or created, but can be transformed from one form to another. Let's move on. Now, after energy, what we go to talk about, we need to think about is what we call work. What we call work. Over there? Work is another term that we are going to apply in the process of talking about energy. What is work? Work is a product of force and distance. This is a product of force. By the way, product. You know what product means? Product means multiplication. So when I say work is a product of force and distance, that's what I mean. Product of force and distance. Now, if work is a product of force and distance, so we say that if work if force is measured in Newton, then distance is measured in meters. Therefore, the unit for work are Newton meter. I hope you have gotten it. What I'm literally saying is this. I'm saying that if you need to know that force, which a letter F stands for. So if you have force, in short form it is F. And if you have distance, in short form it is D. So that means that if work is a product of force and distance, that means that is F times D. Now, force, I want you to see very well. Force is measured in newtons. Force is measured in newtons. And distance is measured in meters. So what will be the units for work? The units of work will be Newton meter. So work is measured in Newton meters. Work is measured in Newton meters. Hope we're together. Work is measured in Newton meters. Now, after work, we need to know. Now, work is measured in Newton meters. I've said that. But another unit for work, another unit that is used to measure work, is also called joules. Joules. So, work is a product of force and distance. Force is short form F, distance D. But force is measured in newtons, over there, and distance is measured in meters. Therefore, work will be measured in Newton meters. But 1 Newton meter is same as 1 joule. So you can also say work is measured in joules. Over there. Now, what is the short form of Newton meters? The short form of Newton meters is N. What is the short form of joules? J. So now you realize that work is measured in Nm, which is Newton meters, and joules, which is J. All together. Now let's go on. We have many forms of energy, and I'll discuss them step by step. I want you to listen very well. I will not be able to write all of them here, but I want you to listen very well. 1, chemical energy. Chemical energy. That's 1. Number 2 is electrical energy. So there is 1 chemical energy. Number 1, chemical energy. Number 2, there's what we call electrical energy. Over there. Number 3, there is what we call the gravitational energy. Gravitational energy. So number 3, we have gravitational energy. Number 4, we have what we call kinetic energy. These are types of energy. Kinetic energy. Number 5, we have what we call mechanical energy. Mechanical energy. That's number 5, I guess. I'm not sure. Mechanical energy. Then we have what we call nuclear energy. Number 6, we have what we call nuclear energy. Number 7, we have what we call light energy. Light energy. Number 8, we have what we call sound energy. Sound energy. And then we have finally what we call the number 9. We have what we call the thermal energy. So I've said we have many types of energy. Number 1, I've just said number 1 is what we call chemical energy. Number 2 is electrical energy. Number 3 is gravitational energy. Number 4, kinetic energy. Number 5, mechanical energy. Number 6, nuclear energy. Number 7, light energy. Number 8, sound energy. And final number 9, thermal energy. So those are the few energies that you need to have just an upper hand information about it. But in grade 5, we are going to talk about only 3. What are we going to talk about? We are going to talk about 1, it is light energy, which is also called solar energy. Then we are going to talk about electrical energy. Then we will finish with one that I'm not written here but I should, which is magnetic energy. Magnetic energy. So let's start with light. Good. As I was saying that we have many types of energy. We have discussed, we have said that we have chemical energy, electrical energy, gravitational energy, kinetic energy, and mechanical energy, nuclear energy, solar or light energy, then sound energy, thermal energy, and magnetic energy we discussed in the previous. Now let's see, in this class we are going to discuss of how many? We are going to discuss of only these 3 that you have written on the board. Number 1 is light energy, electrical energy, then magnetic energy. So we are going to start with light energy. We are going to start with light energy. We are going to start with light energy. Light energy. Now, light energy. Let's see. What is light energy? Light energy is type of energy that causes sensation to the eye. Sensation to the eye, it means that it is causing us to see. Light energy is energy that causes sensation to the eye. What does that mean? It leads us to see. Number 2, it causes illumination. Illumination means that it allows that light goes to an object and makes that object visible to us. So it causes sensation, the eye is able to see, and also it causes the objects surrounding us to be illuminated, to be seen. That's 2. Now, if I ask what is illumination or what is to illuminate? Illuminate means that to cause something to be seen. So I've said, number 1, it causes sensation to the eye, the ability for the eye to see. Number 2, it causes objects to be illuminated, meaning that it causes objects to be seen. Right? Now, what are the properties of light energy? The properties of light energy are 1, light travel in a straight line. Light travel in a straight line. If I had a torch and I show you the light, you'll see it coming direct to you. And this experiment is always done when you get 3 boxes, cut a hole inside the box, try to be on the other side, pass the light ray directly in those holes. You'll see the light direct. I've given this illustration in my notes, you'll get them and you'll see what I'm talking about. Number 2, light can be reflected. When you look at the mirror or you see the cars passing by, then you see the light hits the glass of the car, it reflects in your eye. That means the light can be reflected. Number 3, light can be refracted. Light can be refracted. We mean that when you put, have you ever been to a swimming pool? You stand aside, you see like the depth of the swimming pool is just closer to the swimming pool is shallow. But in true sense, the depth is very far in a clear day and clear water. That means that the light has been refracted. Number 3, light can be diffracted. Light being diffracted, it is like the way the rainbow is formed. The light splits into many colors that we can see the rainbow. That is diffraction. Number 5, light travels very fast at a speed of 300 million meters per second. At a speed of 300 million meters per second. It means that it travels at a high speed. That's why when when there is rain and there is thunderstorm, you'll always see the light shoot, then you hear boom. That means that the light has traveled faster than the sound. So light energy travels faster than sound energy. Then finally, light travels in all directions. What does that mean? It means that when you are in a dark room, then you light your torch or your bulb, you find the whole room has light. Why? Because light has gone through in different direction. Now, I want you to make sure you go through the notes that I'll give out so that you can get more information about this. Let's go directly to how light travels. Traveling in a straight line. In which form does light travel in straight line? It is in the form of a ray. A ray. It travels in form of a ray. What's a ray? This is what we call a ray. And a ray is a straight line through which light travels from the source. A ray is a straight line through which light travels from the source. So, if this is the source, the bulbs, the light is direct to me because there is the rays of light that are coming. Now, a ray can be one, but when there are many, we call them beam. We call them beam. We call them beam. What is a beam? A beam is a collection. Is a collection of rays. A beam is collection of rays. Now, a ray is a straight line that light travels. But now, when straight lines are many of them, we have what we call beams. A beam. So these are beam of light. These are beam of light. Now let's see. If we have beams of light, how many types of beams do we have? We have three types of beams. Three types of beams of light. Types of beams of light. Of light. Types of beams of light. How many types do we have? We have one. Parallel. Parallel beam. Parallel beam, that's one form of type of beam of light. Two, we have what we call, parallel. There are many that goes in one direction. They never meet. Number two, we have what we call convergent. Convergent. Can I say convergent? Convergent beam. Convergent beam. Now, convergent beam is a beam which converges. Converging means that they come together. So, if it was like this, convergent. You see? It converges to one point. Converges to one point. So, that is convergent beam of light. It converges there. Then we have what we call the divergent, number three. Number three is what we call divergent. Divergent means that they diverge. There is a source, then they move into different directions. That is divergent. Okay? So we have three types of beam of light. One is parallel, two convergent, three divergent. Three divergent. Now, after talking about beam of light, let's try and discuss what we call the sources of light. Sources of light. Now, with sources of light, there are two sources of light. These sources of light are grouped or categorized into two groups. The first source of light that we can talk about is what we call natural. Natural source of light. Natural. Natural source of light. That's the first one. The second one is artificial. The second one is artificial. So there is natural source of light and artificial source of light. Now this natural is also called luminous. This natural is also called luminous. And this artificial is non-luminous. What does this mean? It means that natural or luminous source of light, they produce their own light. But artificial source of light, which is non-luminous, they don't produce their own light, but they reflect the light that shines on them. Two differences. Natural, also called luminous, produce their own light. Artificial, also called non-luminous, does not produce their own light. Now let's see the natural source of light. The natural, we have the one which is the main source of light in the world. What is the main source of light? You. Yes, sun. The sun is the main source of light. Sun. Then we have other sources of light that are natural. After sun, we have what we call glowing worm. Then we have what we call firefly. Fireflies. We have comets. Listen. We have asteroids. Comets, asteroids. Comets and asteroids. We have asteroids. We have stars. Those are natural or luminous. We have active volcanoes. Those are natural or luminous source of light. Let's see the artificial sources of light, which are also called non-luminous. The artificial sources of light are one, name any, that is bulbs and lamps. Bulbs, lamps. We have what you call gas lamps. We have what you call fire wax. You know fireworks? You know fire from fuel? You know fire from fuels? We have torches and the banners. Those are artificial source of light. I've said artificial source of light are also called non-luminous, and natural source of light are called luminous. Now, with all this light, what are the uses of light? The first use of light is what we call for seeing. As you can see me, there's a use of light. Number two, photography. You take your camera and take a photo. It uses light. Number four, photosynthesis. What is photosynthesis? The process in which plants make their own food. In the presence of light, we can talk about carbon dioxide and water. Then we have what we call for medication purposes. During x-rays and treatment of cancer, light is a very important component in treatment of this. Then we have in entertainment. When you go to somewhere where there is music, people are dancing, discos, you find light is the fireworks, whereby after parties you do what you know, the fireworks, that is light being used. Now, this is the little part I have for you. Let me summarize. Number one, I said energy, ability to do work. Hope you are getting me. Number two, I said the law of conservation of energy. It says energy can never be created or destroyed, but can be transformed from one form to another. Number three, work. We said work is force, the product between force and distance covered. And we said force is measured in newtons. Distance is measured in meters. So work is measured in Newton meters. And we said product means you multiply F times D. And we agreed that if work is measured in Newton meters. Then 1 Newton meter is equals to 1 joule. So work can be measured in joules. Am I right there? Good. We said that we have many types of energies, but we will name few and study few. We named chemical energy, electrical energy, gravitational energy, sound energy, nuclear energy, and thermal energy. You remember that? And I said we are going to focus most on only 3 in grade 5. 1, light energy. 2, electrical energy. And 3, magnetic energy. I hope we are going together. We say now we start with light energy. What is light energy? Light energy is energy that causes sensation to the eye. What is sensation to the eye? To make it see. And we say it also causes illumination. It causes bodies that are around us to be able to be seen. That's one. We said we have properties of light. The first property of light, we agree that it is light travels in a straight line. The second property of light, we agree that light can be reflected. The third property, we agree light can be refracted. The fourth property, we say light can be diffracted or dispersed. We said that light, that is the sixth now. The sixth property we said, not the five, we said light energy travels at a high speed, that is 300 million per meter second. Per meter, 6 meters per second. And we agree that we see the light, then we hear the thunder during the thunderstorm. Why? Because light energy is very faster than sound energy. And we agree that light travels in all directions. And we said light can be absorbed. We came down and said light travels in rays. And these rays are straight lines in which light travels. And these rays, when there are many, we call them beam. And with beam, we have 3 types of beam. We have a parallel beam, which just goes like this straight. But we have convergent beam, which comes together. It is still here. It converges. Then divergent, which gets away. And we came down and said we are going to talk about the types or the sources of light, because we cannot talk about light and you don't know where it comes from. So we said we have sources of light, and these sources of light, they are 2, which is natural, which is also called luminous, and artificial, which is also called non-luminous. Are we there? Then we came down and said natural sources of light, we have sun, that we agree that sun is the main source of energy. Then we have glowing worm, the firefly, the comets, the asteroid, the stars, and even the active volcanoes. You can also name the minerals that are in rocks. Over there. Then we came and said the artificial sources of light, which are also called non-luminous, are bulbs, lamps, gas lamps, fireworks, fire from fuel. Which fuel? Fuels like the kerosene, the charcoal, the biogas, and the diesel. The torches are also other types of artificial energy. Then we have burners, artificial energy. Now we came down and talked about uses of light. Light can be used in which way? Light can be used for seeing, for photography, for photosynthesis. I've said seeing, photography, photosynthesis, and in medication during x-rays, and also during treatment of cancer. Then finally in entertainment, discos and fireworks. Those are the few things we have discussed today. Now, when you get this video and listen to it, make sure you get the work on email. This work on email, it has all the notes, then the question. So you listen to the teacher, you read the notes, then you answer the question. With that, you'll have understood. So after this, tomorrow we are going to discuss on what we call lengths. Lengths that we are going to talk about. Lengths, not lengths. Lengths, right? Thank you. This is brec.tvonline, your teacher Kisiki, and we were talking about science, and that is light energy. Thank you.